Greetings and welcome to Lesson R.4, Subtraction with Whole Numbers. One of the most difficult things, I believe, is to translate what would be in writing or what we say into math symbols so we can do the math. We're going to start talking about some vocabulary. So the difference of two numbers A and B would be written as A minus B. And here are some more examples using difference. The difference of 9 and 1. In symbols would be 9 minus 1. The difference of 1 and 9 would be 1 minus 9. And if you notice, the order matters. So whichever number I say first comes first. Because the difference of 9 and 1 is certainly not the same number as 1 minus 9. The difference of m and 3, that would be 3 minus m. The difference of x and y, x minus y. 3 subtracted from 8. Now you might just think that it's 3 minus 8, but subtracted from means that we take the second number, 8, and then we subtract 3 from it. So 8 minus 3. So 8 subtract 3. Kind of read it backwards. 2 subtracted from t. Well, what are we subtracting it from? We're subtracting it from t, so t comes first. T minus 2. The difference of 7 and 4 is 3. Well, the difference of 7 and 4, the difference, we just read it from left to right, so 7 minus 4 is 3. The difference of 9 and 3 is 6. So when we see this word is, that means equals. 9 minus 3 equals 6. So we have 8 minus 3, 8 subtract 3, 8 minus 3. So depending on how we want to say this little hyphen, I like to say minus. You'll notice I say minus, I don't say subtract. But subtract is the opposite of addition. So if I said 8 minus 3, I don't know what it equals, but I can figure it out. 8 minus 3 will equal 5. But if I translate it to addition, I can also say, what plus 3 equals 8? Well, 5 plus 3 equals 8. Now we're working with subtraction, so let's look at the long version of subtraction, the vertical. Like we did with the vertical addition, we have vertical subtraction. So all we're going to do is we're going to take our numbers, align them. I find vertical is a little bit easier. And start with the ones column and work to the left. So 6 minus 1 equals 5. 7 minus 4 equals 3. And 3 minus 2 equals 1. So we take it step by step. Now this is great when the numbers on top are more than the numbers that are on the bottom. And we'll get to a little bit harder problem in a little bit. So what's the use of learning subtraction if we actually don't apply it to things around us? That's the usefulness of math, is that we can actually apply it. So let's say a company sells $8,400 worth of product, and we sell that in 1 month. It costs the company $6,300 to make the product, employee salaries, and rent with utilities of the store. What are the profits for the month? Now, when we make money for a company, we call that revenue. So the $8,400 is our revenue. What it takes to make the product, including the salaries, including the rent and the utilities, is our costs. So the $6,300 is going to be our cost. And if we subtract the two, we know what our profits are. So revenue minus cost will equal profit. So 8,400 minus 6,300 is going to be, well, 0 minus 0 is 0. In the tens column, 0 minus 0 equals 0. In the hundreds column, 4 minus 3 equals 1. In the thousands column, 8 minus 6 equals 2. So our profits are going to be 22,100, or you can say 2,100. Now this is nice because the top numbers, our top number, always had values that were equal or greater to the numbers that are in the bottom. But when we don't, when there's a bigger number on the bottom number in any of these columns, we're going to start using borrowing. For example, 92 minus 45. Well, the 2 is certainly less than 5. So here's what happens. I'm going to borrow from the next position to the left, which in this case is the tens position. So I'm going to borrow from the 9 and give it to the 2. So if I borrow 1 from the 9, that becomes an 8. But I didn't borrow just 1, I actually borrowed 10. So when I add that to the 2, it doesn't become a 3, it becomes a 12. Now I can subtract 12 and 5, which will give me 7. And then the last thing is 8 minus 4 equals 4. So I know that 92 minus 45 equals 47. So you just have to remember that you don't add the 1 to the number sitting there. It just becomes the next digit. So the 1 is not added to the 2. It doesn't become a 3. It becomes a 12 because you really took 10 from the 90 and it becomes 80. So let's try an application problem using borrowing. There is $742 in a checking account. A check's written for $615 to pay for rent. How much money is left in the account? Our beginning balance is the $742. Our rent check, $615. So what is the ending balance? Let's start with the 2 and the 5. Well, the 2 is smaller than the 5, so I need to borrow from the 4, changing that to a 3, and giving 10 over to the 2, making it a 12. So now the problem becomes 12 minus 5. 12 minus 5 is 7. Well, now I have 3 minus 1 is a 2, and 7 minus 6 is a 1. So my ending balance in the checking account is 127. Subtraction with borrowing does take a little bit of practice, so I highly recommend doing homework or practicing with difficult problems. Just create them yourself and work through the process, starting with the ones column. Do you need to borrow? If you borrow, go to the tens column. If there's nothing to borrow from the tens column, you need to go to the next column, like the hundreds column, and bring it back and bring it back and bring it back. And I'll show you one of those problems in a future video. So until then, be seeing you.